Okay, this is for the students gone for the SAT. We're starting with the handout. This is available on the drive. So first one, we did this in class, but this is just asking to find the area between the curve or the function and the x-axis. The first one's 15 because from -1 to 4, the area of this rectangle is 15. Okay, from 4 to 9. Can I get a hand from 4 to 9? What was the area from 4 to 9? Anybody?
7.5.
7.5, because that's the area of this triangle was 7.5. Okay? Good on that one? Okay, now this is a review of summation notation. How do we evaluate this? We start at what value? We start at 1, and we're just going to replace k with 1. So it's going to be 1 times 3 minus 1 squared, and then plus. Now we're on, what next? After 1 comes 2. So it's 2, then 3 times 2 minus 1 squared. Then it comes 3, so it's plus 3 times 9 minus 1 squared. Then plus, last one, 4. 4 times 12 minus 1 squared. And do I go any further? No, because 4 is my end. This altogether, I believe, is 730. Did anybody do it? 730. Okay. The bottom three here are rewriting a summation expansion in summation form. So summation form, we're going to write our sigma here. When we look at this expression, this expansion, what is staying the same for each? 3 times 4. So the 3 times 4 is going to stay. And what's changing? It's the exponent. So that's going to be your k, or your I, or whatever you want it to be. So we start at what k? K equals 1, and where do I end? 4. Very good. Okay, the next one, 9, 16, 25, 36. Is there a pattern here? What are all of these? These are all, they're all perfect squares. They're k squared, like Mate said. So it's k squared. And then where do I start? Where do I end? We start at 3. We end at 6. Okay? Making sense? Okay, last one. So I do the same thing. What's staying the same each time? What's always there? There's always a 1/2. Good. And the f of, well, this is changing. Something in here is changing. Okay? Where do I start? I'm going to start at 0. Okay? And how many terms are there? There's 1, 2, 3, 4, 5 terms. So I'm going to go up to 4 because you count 0, right? 0, 1, 2, 3, 4. And then if I wanted to go up by 2 each time, it's going to be 2k in here, right? That means when I plug in a 0, it's 0. When I plug in a 1, it's 2, 2, 4, 3, 6, 4, 8. Okay? How are we doing on that? Feeling good? Okay. Can we get the notes out? Can we go to 11 point? I'm on the notes packet. I'm on 11.2. This is Introduction to Area Under the Curve. Okay. So there are 2 big essential questions in calculus. 2 big essential questions. One of them is about area. So what is the area under the curve of any given function? So something interesting about calculus is that when we say curve just means function. So I just want to make that clear. Curve just means function. The curve doesn't mean like it has to be a curve. It's just any.
Curve just has to be.
It could be a line. Yeah.
So what does that say?
Curve equals function.
Okay.
Sorry about that. Okay. So we have 2 cases here, right? So on the right side here, we have this is what kind of function? This is a linear function. And could you get the area of this right here using geometry?
Yes.
Yes. You could make a triangle here, and you get the area of the square and the area of the triangle and add them up. Easy. You could do this. But then over here we have what kind of function is this? This is a not parabol, but polynomial. It's polynomial. And so could we, using geometry, get the area of this? No, right? This doesn't divide up into nice squares and rectangles. So this is hard, right? So this is easy. You can do this. This is hard. Like, how do we do this? Calculus answers this question of how do we find the area of this? Like, this is calculus. How do you find the area of this region? Okay? This is also calculus, but we're just introducing the notation. We're going to focus on the left side today, just to get you used to, well, what is an integral? Okay, so that's the next part. In calculus, when we talk about integrals, in a really simple way, integral just means the area under the curve. So we have these 2 symbols. You have this S. It is an S. I know it looks funny. It looks kind of like an F almost, but it's an S. And it is related to the sigma we did last class. So again, this is sigma. And this S comes from the German Summe, meaning sum. And these are related. Okay? So let's read the integral notation. Again, you don't really need to know like the full detail of it, but I'm going to teach you like the general gist of it. We have the integral symbol. The A is going to be your start point. The B is going to be your end. The f of x inside here is the integrand. Integrand. To what you're integrating or what you're finding the area of. The way that we read an integral is we're saying, what's the area between the curve and the x-axis between this x value and this x value? That's how you read it. And it's the signed area. We'll talk about that in a second. Signed area. Okay. So as an example, on the right side, you see we're taking the integral from a to b of f of x dx. That means the area between a and b underneath the curve, between the curve and the x-axis. Does that make sense? Are we following? Can I get some like head nods or something? The integrand is what you're integrating, and to integrate something in really simple terms means to find the area between two x values. Okay? So as an example, the dx we'll get to later. The dx, you don't need to know that. That's just like a placeholder. That doesn't affect anything. It's always a dx. So as an example, we're taking the integral from -5 to 9 of f of x dx. This is saying, in English, what is this saying to do? In words. It's saying, find the area between the function and the x-axis between -5 and 9. The way that I recommend that you evaluate these is do a little mark. Okay, I'm going from -5 to 9. And I need to find the area of all these regions between the function and the x-axis. Can you guys try that? Can we do it? Okay, I'm going to give you a minute to find the area. I'm going to pause the recording for a second. Okay, Nikos, what's the area of this first square here? This is?
It is 25.
That's 25. What about this triangle right here, Mate?
5.
What about this triangle right here, August?
4.56.
4.5.
4.6. 12.
How about this rectangle here?
2.5. The whole triangle.
12, and this is 6. Well, it's two separate triangles, right? You see that?
Yeah.
The triangles aren't the same. So in total, I got 52.5. Did we get 52.5?
Yes.
Okay. Are we following that okay? It's not too bad, right? You're just finding the area of rectangles and squares and triangles and adding them together, okay? So what are some applications of integrals? Integrals are useful because they tell you a quantity. So for example, I did this on the board earlier. You probably learned this in physics or chemistry or your other classes. If you have miles per hour as a function, and on the bottom you have hours, and you get the area here, what does that tell you?
Miles.
It tells you miles, because what you're doing is you're multiplying the number of hours by the miles per hour. The hours cancel, and it just gives you the miles. So the area, the integral of a rate gives you quantity. That's such like a big calculus theme in the AP test and in other aspects.
Integral of a rate gives quantity.
The integral of a rate will give you the quantity of that rate. The area underneath a rate will give you the quantity of that rate. So, for example, if our function was velocity in miles per hour, and I got the area under the curve, what would that give you? That would just give you miles. If it was Cheetos per minute, it would just give you Cheetos. If it was gallons per second, it would just give you gallons. Okay? That's a really key theme in calculus. Okay? Are we following so far? We're doing okay? All right, I'm going to do, if you go to your handout, I'm going to do the first problem with you, and then I'm going to let you do the rest, and then you'll have some homework time. So these are like your delta problems. Let's read the first one together. The regions A, B, C, and D in the figure below are bounded by the graph of the function f and the x-axis. The region of area A is 5, region B is 6, and the area of region C is 11, and the region of region D is 10. What is the value of the integral from negative 8 to 8 of f of x dx? Okay, so one thing I mentioned before is that it's going to be the signed area.
Is this on calculator?
No, this is, you do not need a calculator.
You have to just add together.
Correct. So we're going from negative 8 to 8. What's the area of A? 5. The area of C?
6.
11.
C is 11. B is 6. And D is...
10.
But here's the thing. I said signed area. So do you understand what that might mean? What do you think signed area means?
Sine.
Signed area means that if it's above the x-axis, that is positive area, and below the x-axis is negative. So there's not a 6, it's a negative 6, it's not a 10, it's a negative 10. We're going to add all these together, 5 plus 11 minus 6 minus 10. What do you get?
0.
Just 0. So we say the integral from negative 8 to 8 of f of x dx is just 0, because the signed area between negative 8 and 8 is 0. Are you guys following that? Yeah.
So what is D?
What is dx? So dx is a placeholder. I'm kind of introducing the notation like a little bit early, but you don't have to worry about the dx. The dx, we'll talk about what that means later. Don't worry about the dx. Okay.
So basically, what is under x-axis is going to be negative.
Yes. If it's under the x-axis, it's negative. Can you guys try 2, 3, and 4? The rest of the page by yourself?
Yes.
Okay. I'm going to walk around. Okay, here we go. Okay. So let's start with number 2. We are finding the area from negative 9 to 6. So we're going to mark that. Negative 9 here, 6 here. And let's get the area. So we've got a rectangle, a triangle, and then a square. So this is 9. This here I think is, so it's 1, 2, 3, 4, 5 by 3. This is 7.5. This is 7.5. And this is 6. So all together, that's 30. Did we get 30 for number 2?
Yes.
Good. Okay. In number 3, we have from 0 to 9. So starting here and ending here. Not the whole thing, just 0 to 9. And we want the area between the curve and the x-axis. So here, here, and then here. This is 2 by 5. This is a 5. This is negative 5. This is 3 by 5. This is negative 15. And then there's another negative 5. So all together, this should be negative 20. Do we get negative 20 for 3?
Yes.
Okay. O2, you want to do number 4?
Yeah.
All right, come up.
Okay, so we have to find like the area, like the half circle.
So we want the area here.
Yeah. Okay. So let's see. So we have 5, 2, 3, 4, 5, 4 squared over 2, since it's a half circle. And
Okay.
then equals 41. And that's important. We're gonna need that later. And then we have to find the area of this big rectangle here.
Okay.
But first we'll do this part here.
So it's negative 9 to 3. Yep.
And then let's see here. 1, 2, 3, 4. 1, 2, 8, 4. It's positive 4. It's a negative 41. And then let's see. One. I went through this little part here, right? This part?
Yep.
Okay. I think it's the same thing, right? 1, 2, 3, 4. Yeah. This one's negative 4.
Good.
And then let's see. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 4, 8, 32. 32. And then we have to subtract. Wait,
Yeah.
do we have to subtract like this area?
You did that. So you got pi r squared over 2 is 41,
Mhm.
and then you have the rectangle.
And what's the next step here?
So the area of the rectangle is 32.
Yeah.
And then, but you have to subtract the half circle, so the pi r squared over 2, but I don't think that's 41.
It's 25.1.
It's
Oh, okay.
25.1.
Yeah.
So it's going to be 32, push it down, or up, but push it up a bit, there you go. So
25.1?
25.1, so?
Yeah.
So it's going to be 32 minus 25.1. What does that come out to?
6.9.
6.9.
Yeah.
But is that positive or negative?
Negative.
It's negative because it's below the x-axis. Okay, thank you. Great job. All right, so like just to recap that, it's the area from -9 to 3. These two triangles cancel out because they're both 4 and -4. Then to find the area of this shaded region here and here, you would take the area of the full rectangle here, which was 32, and then subtract this half circle, which was pi r squared over 2. That value was 25.1, and so we subtracted and we got 6.9. Okay? All right.